Here we are, part three of six series. We should have a bit file generated, so we should have successfully gone through synthesis, place and route, and the bit file generation. Um, and so in this video, we'll download the the bit file to the FPGA, see what that's all about. Should be straightforward. Um, And yeah, maybe we'll look at some of the reports first before we do that. So let's get going. All right, so this is the screen that happened. That should have left off. Hopefully you're here. Uh, Everything is saved in this pane right here. We've got a lot of reports that from each stage of the pipeline of going from Verilog or VHDL or schematics all the way through to the bit files. One of the place where you're probably often going to look is the SRR file, SRR. And this file, you get a lot of warnings, a lot of, and errors will appear here. So warnings start with this at W, errors start with an at E. So that'll help you find errors if you have to be digging through this file. So this is a very important file. Another file, let's see if we can find where let's see how many resources, compile netlist resources. So this is probably an interesting file here. So in here, it gives some nice statistics here. Let's see if we can make this a little bit bigger for us. Um, so in this, we've got Polarfire SoC. The 250T. Um, it's got the MPFS, which is the SoC version. So it's got processors. It's got the RISC processors in it. It's in the package 484. This is all from the Icicle, so this should line up perfectly with the Icicle. Um, if it doesn't, then we couldn't download it. We'd probably have issues downloading the Icicle. Speed grade is standard. They have a faster speed as well. Core voltage is 1.05. You could also run it at 1.00 if you wanted to save some power. 1.05, a little more voltage, a little more speed. Um, so this part is good for the extended range. So this should all line up with the actual part that's on the FPGA. I'm assuming it's correct because Microchip did this. Um, but you'd want to make sure that if you're on your own design, that this is all correct. Um, got some source files. Now this gets into the resources. So they got this that's a 4-input lookup table where 4 inputs go in, goes into this lookup table, and an output pops out of that based upon those 4 inputs. Right here it's saying that we use 16,831 out of a total 254,196. So we're only using 6.6% of all the lookup tables that are in this FPGA. So we're using a very small percentage of it. We have a lot of room to grow. And kind of what that means to me as well is this design could probably easily fit into the Beagle V-Fire, which is using a 25 instead of a 250. It's using an 025. So it's like 10 times smaller. So if it's just 10 times bigger, then you're still at 60% utilization. So the Beagle V Fire, even though it's much smaller, you can probably do some pretty interesting things with it. Um, we got this RAM here, so it's got different types of embedded memory. Um, and we can dig into that in much future videos. DFF stands for D flip flop, and so we're using like 5.45% of the available D flip flops. IO registered, we're not using any of them. That's essentially when your IO goes out, you have a flip flop built into the IO cell. And in this design, they're not using any. user I/O. So we're using 67 I/O bins for this FPGA. We have a total of 144. So we're only using like about half the I/O. So potentially we could have a design, if it's wired into this board, with much more I/O. PLLs and DLLs. These are phase lock loop and delay lock loop. And those are how we generate from a slow speed clock a faster high speed clock. Um, so we only have 8 of those. We're only using one. Um, and yeah, but MSS, that's the microprocessor subsystem. We only have one of them, and we're using it. That's nice to know. Um, So anyway, that's a bunch of the statistics that you can get out of like the utilization. So that's kind of interesting. And you don't want to hear me blather on. You can dig through all of these different reports for pin reports, bank reports, delay reports, all sorts of stuff. Maybe in future videos we might have a great time of digging through these reports, but I don't think anyone wants to hear it now. Um, Another interesting thing is if we take and we move over to this design flow pane. So remember, you can switch between different ones. But most likely on the design flow pane, since you just finished your synthesis. You can scroll up and you can see, I don't know why it's yelling at us for constraints, but we won't worry about that because, well, our constraints derived from your design are out of date. So maybe that's why this has got a exclamation mark too. I think we'll live with that for now. Um, it's a time to debug that later. But you end up getting these checkboxes as it passes each stage. So you got a bunch of checkboxes, and you should see checkboxes all the way down to generate bitstream, which means that we generated a bitstream, and it's ready to be loaded onto the Icicle dev board. And so right now I've got the Icicle dev board connected. It's powered up. It's connected with the FlashPro 5 uh, uh, programmer. Um, there's an embedded, and by default, the Icicle is configured to use an external FlashPro 5. Um, the Icicle does have a built-in Icicle FlashPro 6, so you can use that, and I have used that. You have to set a jumper that's on your Icicle board. So take a look at the user guide for the Icicle board to see what jumper you have to set if you want to use that in embedded Icicle. I'd recommend doing that. That saves you a few dollars on buying a FlashPro 5. Um, so we've got the FlashPro 5 hooked up. The board is powered up. And so now we're going to cruise down through. And what are we looking for here? Here, right here, this one here, this Run Pro Action. That's what we're going to double click. Seems like a silly name to do it, but this Run Program Action is what you click, which will actually do the programming action. And so I think we're ready to do it. Yeah. So here we go. Double click. That was a double left click. We get this little prompt here, a little pop up saying running program action. Please do not interrupt. And so we won't interrupt, and we'll let it go. You probably see on your dev board, oops, I got some reds, oranges, and green lights going on now. So it's showing that it's doing something on that board. And besides that, it'll take a few minutes to program. And I'm going to probably be quiet for the rest of this. So it's around 9 minutes and 20 seconds into the video. The remainder of this video, I'll just be quiet and we'll be doing the programming. And then if it completes successfully, so on my FlashPro 5, I've got I've got a green power LED and a flashing yellow LED for activity. And so that's all running. Yeah, I think that's about all I could talk about here. So let it run. And then after that, we will pick up where we start modifying the the gateware, the fabric, so that we can control that blinky. And then we'll control it with a processor. We'll control it with some code, C code, and then we'll control it with PuTTY through the C code. So those are the remaining videos that I hope to create in the near future. I think that's all. Take care. Bye-bye. No, actually, I'll just leave this running until it completes, but no more talking. Oh, well, I guess you get a little more talking. That didn't take much longer than I thought. So it took a couple minutes to program, and it's done. Um, and I think that's about it. Until the next video. Shutting down. Shift print screen on the Screen X screen recording program.